Okay, so I'm working on my hex. Sorry if there's a bit of shake. My hexacopter. I've got my multi-star 40 amp ESCs. I got my Tenergy 35, 36 /8 1000 kV motors. So what I needed to do, because I'm really picky, so these came with bullet connectors, so you could actually connect the motor straight into the ESC, but I've desoldered them because what I'm going to do actually is I dismantled this ESC. Well, actually, I dismantled all of the ESCs. So this is what it looked like. It had the signal cable coming in this side. It had the power cables coming in this side. They were nicely bullet connected. It had the 3 AC leads for the motor coming out. They were nicely bullet connected. My other ones actually weren't. I was surprised to see these had bullet connectors. That was really nice. Although I wasn't using the bullet connectors, but it was still really nice to see it on there. So cut open the ESC, and actually, of course, all these wires were soldered on, and it was actually a pain in the ass trying to desolder these because these are some thick-ass wires. This is the ESC. This is what it looks like. It's Atmel based. Gonna focus? Oh, whatever. It's a Atmel Mega based processor in here, which comes pre-installed with BL Heli. Yeah, BL Heli. It even shows here that BL Heli is pre-installed. So you don't have to tear it apart to put a bootloader on it. It's already got the bootloader, and you can actually just go ahead and do it through the signal wires. Now these don't have BECs, battery elimination circuits, so 5 volts doesn't come back from this to power your transmitter or anything. So you have to actually do your own BECs, and I've got some custom parts to make some BECs, so that's not a big deal. So what I'm going to do actually is going to solder these motors directly on here. Well, actually, they'll probably be about this short. The arms of the Tenergy Hexacopter that I have. This is what the bottom side of the arm looks like, and the ESC is going to sit right here actually. And I'm going to solder it directly on right here. Cut the wire, solder it directly on. Then I have more 14 gauge wire that I purchased. I've got a couple yards of it. And then what I'm going to do is I'm going to take the power cables, hook them on here, wrap them around. After they're soldered on, they will be wrapped around, and then run along the inside and the opposite side like this. Positive and negative, and then the power wires are actually going to run back in here and through the center tube out to the inside of the hexacopter assembly. So there won't be any wires running along the stretch of tubing here. And then after this is soldered on and the power wires are soldered on, I'm actually going to run a it'll be like this. The heatsink will be on the downside, so it'll be facing outward, so it can dissipate heat pretty well. And these will be nice and short, so there'll be no really much power loss from at least the BEC or the ESC to the motor here, and it's just temporarily mounted because I'm probably gonna have to move it a lot. And then since the wires are gonna run back, I'm just gonna run a heat shrink tubing over, so there's gonna be no wires coming out here. There's going to be a black blob of heat shrink that's going to cover this, and then I'm going to zip tie it, of course, down to this assembly right here. And then when it's on the underside, it will kind of just meld in. Looking underneath here, there'll be a like a short black tube is kind of what it'll look like when it's all hooked up. Now, getting these motors on these arms was actually quite the challenge. So let me show you different sizes of motors. Here's my tricopter. Now these are also Tenergy motors. These are 2830s/11s, also 1000 kVs. These are 15 amp, maybe, somewhere around there, and these are almost 30 amps. I think they're like 28 amps. But if you look at the size difference, it's like, holy shit. Like, it's no joke. Originally, I was going to put this on my tricopter, but the mounts that came with the tricopter here wouldn't fit this. I would have had to do some modding on it, and I didn't want to do it at the time. But it'll actually kind of look like this, although with this one I have the wires coming in right here, just because the way this whole assembly works, it was just in right here, out right here, and the wires run in through the tubing along with the signal wires, and these have BECs inside of them. These are Tenergy 20 amp ESCs with built-in BECs, and these are also connected on by zip ties, and then of course they go through and they go all the way in and into the center part of the tricopter here, which needs a little bit of work because they wrecked it. But to get them to fit, I had to do a little bit of modification. Let me show you this part right here. These are some nice ball bearings that connect the unit, since the these are quite interesting motors. I haven't actually seen motors like this until I started getting into multi-rotors and stuff like this. But this shaft right here, which is usually the only part that spins, is solidly connected to this, and the stator and the rotor are actually opposite. So the way they work, since now this is AC, the whole outside casing spins instead of the inside. The inside stays the same. If you look, the inside there, it doesn't move at all. This entire outside connection here spins 1,000 RPM per volt, which is what the kV means. Every volt you put into this, it'll spin 1,000 RPM. Of course, it's under no load. That's optimum how it would work out. But the size for this, these holes right here were actually too small, and so when you would try to put it on here, the inside ball bearings there was actually pushing up against this. So I had to modify each and every one of these, and I was using a Dremel at first, and it was taking forever, and eventually I had some giant metal drill bits, and so I drilled this connection here out. And so even though the outside here is still rather small, it doesn't matter since it actually sits inside there. And then of course you just screw the bottom on, and the entire top assembly spins. Of course, when I've got them this way and underneath. I'm really picky about wire management. So this is a hexacopter, so I had to modify all 6 arms, which took a while. I only have 4 ESCs at the moment. Originally I was going to build a quadcopter, but I ordered the rest of the pieces and they should be here soon, and I only have 4 motors. So I'm going to work on these 4 motors and 4 ESCs and get them all soldered in and installed onto the body of the hexacopter. Although it'll probably take several days, since I'm really picky about how I do all the work on this. And and a small problem. So the blades I have, these are the assembly, since the blades actually go on this top assembly part here. So, and then this goes on this, and then this goes on top to squeeze it, and then the bolt goes on top. Now the problem is these are 6mm holes, I believe, and these are 8mm shafts, which is rather rare. 6mm is kind of the common size, and these actually are meant to hold smaller shafts too. They come with little rings that you can put inside of here to go for different sizes. And I modified, oh, that's not the one. I modified one to fit on, and these are nice carbon fiber blades, although these are the smaller ones. These are, I think they're 9.5s, I believe, but they've got smaller surface areas versus these ones right here. So of course they have different thrust profiles. But I mounted this one on yesterday. I used actually a drill bit to drill it out. The drill bit I used was actually the same size as the beginning shaft here. This is 8mm. So I was using an 8mm bit. And so it was able to kind of guide it and drill it straight through. Now, unfortunately, if you drill something out like that, it's going to throw the balance off a tad bit. And these look like they were, you know, some grinding on here. So it looks like it was probably pre-balanced. Although I haven't put it on my balancer yet since I'm not done with the rest of the thing. The balancing is kind of the last thing I plan on doing. So drilling out the holes in the blades is going to throw the balance off. I know it. So I'm going to have to drill these all down. They're going to have to be rebalanced when they're mounted onto the motors. Well, they'll be balanced beforehand and add some taper depending on how much I need. Maybe grind some of the blades down, although I don't like these blades. These ones are definitely going to have a bit more thrust. They're wider at the end. This is higher speed, but I want a bit more efficiency, which is going to run at your lower speeds, and you're going to use your bigger prop size. Of course, it all depends on your motor profile. You look that up. There's data sheets for it. So I hooked this up to it yesterday, and I hooked it into my vise. Actually, this assembly right here. When it still had the bullet connectors on it, before I unsoldered everything, I hooked it all up, and I mounted this into my vise. I had a nice strong vise connected, and I put the prop on it, and I ran it up, and it's I think it's 30 amps, and I got it up to, I think maybe 15. It was about 75% throttle probably, and I thought I was gonna rip my desk apart. Like, I was terrified. The thrust it was putting out was insane, even for these, these kind of higher speed, lower catch props here. And I was afraid to ramp it all the way up. I thought it was gonna rip the entire assembly apart. It was wild. And then there's 6 of these that are going on. So when it's all over, we'll see. All right, I'll do another update from my friends later.